Okay, hi everyone. I'm going to give you an example of our method for balancing a siphonic system. This will just be a real simple system. The purpose of this is simply to kind of walk you through the steps and give you a narrated tour, if you will. So the software is hosted on a remote desktop server, and I've created a desktop shortcut to the login page here. So I'm just going to click on that, and it's going to open up in my internet browser, which is Google Chrome, but it could be whatever browser you're using. So when you get to the gateway here, you're going to type in your username and password and just click log on. And then it's going to ask us if we want to log on or install Citrix. I've already got it installed, so I don't need to install it. I'm just going to log on. If you haven't installed it, go ahead and um, click the license agreement and install the Citrix receiver. But I'm just going to log on, and then I'm going to click here to connect to the remote desktop. And that'll take just a second to open, depending on your internet speed. I'll maximize the window, and then you'll see I'm on the remote desktop. I can then open the Siphonic software. Again, it's going to ask for your username, but you do not have to enter a password again at this point. So I'm just going to put in my username and click login. And I'm going to close this quickly and just show you how to start from scratch. File, new. We've got a little wizard here you can work with. Um, we're just going to do a straight run right now, so I can give you a quick idea of how this should work. And then we're going to put in our design details here. So the first thing we need to know is what the design rainfall rate is going to be. And for this one, I'm just going to say it's around 900 gallons per minute. We need to tell it what kind of pipe we're going to be using. We'll use PVC for this one. PVC comes in maximum lengths of 20 feet, so we're going to enter that. Minimum and maximum pipe diameter are optional. You don't have to choose those unless it's uh, a situation where you don't have enough room for a certain pipe diameter and you need to keep it to a certain size. You can put in a maximum and see if you can get it to balance according to your preferences. So I'm going to minimize that box, and then we'll look at the underground. We'll go ahead and assuming that the siphonic system is going to run to the outside of the building and break to gravity below grade. We're going to add some underground here. Obviously, we could break back to gravity inside of the building, and in which case we wouldn't need to do this at all. We would just leave this box blank. We can set the diameter if we want to. I'm not going to do that. I'm going to let the system figure it out for me. The underground drop, we'll imagine is going to be 4 feet and maybe 5 feet of horizontal underground pipe before we make our break or our civil connection. So down pipe, assuming this is a one-story building, a warehouse or a distribution center of some kind, maybe 16 feet of down pipe, minimize that. The other options here, stepped down pipe or swan neck, you can sort of imagine what that might mean. Those are just offsets in the vertical pipe. But to keep it simple, we're not going to add those. The branches box is for systems with multiple branches. We don't need to worry about this right now. We're going to disregard that and just keep the system a single branch system. Now, a transporter is the portion of the vertical pipe, or excuse me, the horizontal pipe between the vertical down drop and the horizontal collector pipe, which is our main pipe that runs along the building and collects all the tailpipes. So this is going to be typically your shortest length of horizontal pipe here. It's probably 4 or 5 feet in most cases. just to go back to the corner of the building. We'll minimize that, and the collector then is the main collection pipe, as its name indicates, that catches all of our tailpipes. So this is going to be our longest section of horizontal pipe, and we'll say in this instance that we've got 4 drains. You can see the line drawing over here starting to outline our pipe routing. Now this box right here assumes that the drains are equal distance apart. If they're not, we can change that on the next page, which is the design interface. And now we've got to tell it give it the dimensions of our tailpipes, the vertical and the horizontal dimensions. So we'll say roughly 6 feet of pipe from the drain to the collector, with a drop of maybe 3 feet. And then we need to choose our drain size. We'll try to do this one with 3-inch. That's something that we're just going to assume and kind of tell it what we want to work with, and is easily changeable on the next page in the design interface. So that's all the critical information we need to get started here. Then we're going to click balance and give the system a chance to do this automatically for us. Rarely do we nail it in one try, but it's going to bring us sort of close. And you can see we have a system that has a residual head of 10.75 feet. We need to get that down to 1 foot or less. So we're going to start here with the tailpipe A4 because it's the furthest out of balance. I usually want to try and bring those close before I start to mess with the other tailpipes. You can see that tailpipe A3 is already in balance. That's why it's in black text and not in red. So there's no problem there. The red text indicates we've got a problem. We can hover over it and it will give us a little bit of a suggestion as to what we might need to do. In this case, these tailpipes are over capacity. So it's telling us we need to try throttling the system. In other words, make the pipe and fittings smaller. So that's what we're going to do, and I like to look at these in the 3D section view as I'm working on them, just to get a nice visual of what I'm doing and what I'm changing. Isometric view seems to be the easiest to see, so I'm going to start there. And you can see here we're quite a bit over capacity and we need to shrink this pipe. So what I'm going to try to do first is I'm going to change all of this pipe here, including the 90-degree bend and the horizontal. I'm going to try changing all of that to 2-inch and just see where that gets us. And that did it. Just one try, and it brought us into balance. It's not always that easy. Sometimes there's a lot more trial and error that needs to take place. Maybe we'll see that in the next few tailpipes we're working on here, but that one was real easy. So let's move on to A2. You can see we're slightly over capacity on this one, and we've got some stuff that's a little unusual in this one. ASPE 45 recommends as a general rule that we don't have any reductions in the horizontal. It's not entirely prohibited, but I don't like to see it, and I like to make these systems look as much like a conventional drainage system as is possible. Siphonix, as you may or may not know, does allow and even encourages reduction of diameter in the vertical portion of the piping, but it's not generally recommended in the horizontal portion. So this one's a little over capacity, and I'm gonna just see what happens if I change this length of horizontal pipe in this 90 right here and right here to 2-inch. I think that's going to put us under capacity a bit, but let's see what happens. Okay, it did put us a little bit under capacity, so I'm going to go to the furthest downstream point of the tailpipe here and work my way backwards and try and keep it somewhat conventional. So the first thing I want to do, I want to try and leave all of this as 2" and maybe just change this bend right here to 2.5 where it enters the collector. Change that diameter to 2.5. That put us quite a bit above capacity again. So I didn't really like that change, and one of the nice things about Siphonix software compared to other Siphonic calculation systems is that it lets us see the effect of each individual change as we make them, instead of simply having to make a change and then recalculate the whole system every time. It also allows us to back up. So you can right click and hit undo last change, and it's going to take us back to where we were. And I need to figure out a different way to get there now. So still a little under capacity. What I can do, because we're allowed to have the reduction in the vertical, I'm going to attempt to change this portion of 2" pipe here to 2.5" and then reduce as we go into the 90-degree bend here. And that's brought us into balance. So we've got a 3" drain connecting to 2.5" pipe, which then reduces to 2" in the vertical portion as it enters this 90-degree bend, and then the rest of the tailpipe here is 2" going all the way down to the collector. Let's see what we can do with A1. So A1, slightly over capacity as well. Again, it's given us some reductions in the horizontal, which I don't want to see. I'm going to change those to 2.5 and then kind of work my way. Well, I'll tell you what, I'm not going to do that. I'm going to first change, just like we did on the last one, I'm going to change the vertical and the 90-degree bend coming out of the vertical to 2". And that's brought us real close, but we're very slightly under capacity there. So I'm going to try and do what we did on the last one and change this vertical portion from 2" to 2.5 and then reduce to 2 in the 90-degree bend. This tailpipe obviously is a little bit different from the last one, and it may put us over capacity, but let's give it a shot. Okay, it did bring us slightly over capacity. So what I want to do now in this vertical portion of piping, this 3 feet of 2.5". I'm going to split that pipe and make a portion of that 2" because we're over capacity and we need to throttle it a bit. So I'm going to right click on it and we're going to click on split pipe, specific lengths and diameters. I'm going to try cutting it right in half and see if that works in equal portions. If it doesn't, we can adjust the lengths afterwards. So the downstream pipe, we're going to reduce to 2". We're going to leave the upstream pipe as it is, coming right out of the drain at 2.5". And there we go, that did it. That brought us in balance, pretty close to the limit here, but we've got a balanced system, a viable system that exceeds the requirements of ASPE 45, which is the Design, Performance, and Installation Standard for Siphonic systems in the U.S. The software actually has more rigid requirements than what ASPE 45 requires. So if you've got a balanced system, you know, as approved by this Siphonic software, then you don't need to worry that you're going to somehow be in conflict with the requirements of ASPE 45. You're always going to exceed what's required there. We've got a residual head of 0.25 feet, which is well in excess of what we're required to have. And now we want to output our reports here. So we can right click here and we can look at the whole system in 3D just to get a visual. Unfortunately, At this time, we don't have any way to dimension or export this model. It's just something you can look at and rotate and just get a nice visual representation of what you created. Close that, and we're going to save this. I'm just going to call it example. I'll overwrite my previous example that's in there. And we can put in a summary of the changes we've made every time we save this if we'd like to. I want to output it to PDF and create a report. So the first thing I need to do is go to File, Status, and Audit, and change the status from draft to design. Click OK. Now we can create some output. I'm going to PDF the system details, and there are a variety of things you can output here. The system calculations are critical. We can click design issues if there's anything wants to warn us about it. It'll tell us that. We'll output our system drawing here and the system summary in general. You can click all these other things. They're not generally necessary. You probably will want more information the closer you get to a final design, but for a preliminary design, for budgeting, then what we've checked on here is more than enough. So we're going to click Output. You can see we'll get a message that tells us the current isometric will be replaced with the printable version. We can rotate, pan, and zoom until we're happy with it. We need to go back to the System tab here and move away from the 3D view to the System tab. And we'll just rotate this to where it looks something like what we want to print and share with our customer. And this is not a dimensioned isometric, unfortunately. That's something we can do in AutoCAD. We'll just duplicate the system in AutoCAD. Or Revit, and we can provide an isometric or a 3D model if you need. That's something that will take us a couple of extra days, and it's something we typically do, the closer we get to a final installation drawing. So now I've zoomed in, and I've got this little line drawing here the way I want it to look, and I double click on that. And we want to save it. And remember that we are on a remote desktop here, so find your local disk. It's a good idea to put a shortcut in here. That's a little quicker to get to, but I'm going to navigate there. I don't want Windows. Users. That's me. And I'll just save it on my desktop for now. But again, you can put in a shortcut into this list here to make saving it a bit quicker for you. And I'm just going to overwrite my previous example again here for demonstration purposes. So now that's done. I can close this, save any changes we made, exit the remote desktop. You can disconnect if you're ready to disconnect. And here's my example. So this gives us just the summary of the design, some of the hydraulic data, tells us if anything's wrong, tells us our discharge velocity, our pressure, our fill time, etc. And here's our line drawing. Let's zoom out here so we can see a little bit better. And then here's our calculation report. And what this tells us is it simply gives us a list of all of our pipe lengths and diameters and fitting sizes itemized per section. Our discharge, for instance, is telling us every piece of pipe we need, every fitting we need, discharge, down pipe, collector A1, A2, A3, A4, and then again the same for the tailpipes. This also, the bill of materials here, also includes your drain. In this case, a Wade WH300. So you can use this list to estimate the cost of your materials and see what you potentially could be saving over a traditional gravity system. You can send this list to your suppliers, obviously, and have them quote the system for you. And that's pretty much it. Thanks for watching. That was a simple system. Obviously, complex systems with multiple branches can take a lot more time and a lot more trial and error. But what I showed you today is a pretty good example of what a simple system would be, a single branch system that can take just a few minutes. Likewise, we can make changes to the system as they occur in the field. We can attempt to rebalance and do it within a matter of minutes. Um, so that's it. I'll follow up with some more videos. And thanks for being a Wade customer and for using Siphonic software.